Hi everyone, welcome to this lecture on biomass energy for AP Environmental Science. For this lecture, we're going to be looking at two topics or two learning objectives. The first is fuel types and uses. The enduring understanding for almost all of the things in this unit is going to be that humans use energy from a variety of sources, resulting in positive and negative consequences. I want you guys to take away that every single fuel source has both positive and negative consequences. Um, you'll notice a couple things specific about wood, charcoal, and peat on the left, and then talking about burning biomass over on the right. As usual, I'll skip the vocab, but you can pause it now and write it down, but let's just get into it. So for this lecture on biomass, we're going to be talking only about primary biomass. That's going to be the wood or the charcoal that you burn. We're not going to talk about waste products like paper or cardboard that can be burned for energy. That'll be in our waste incineration lecture. And then the biofuels will be in the biofuels lecture. So this is just going to be on primary biomass. Whenever you burn anything, you're going to be releasing carbon dioxide and water. So we're looking at those combustion reactions again. And again, whenever you combust anything, you're going to be releasing carbon dioxide. However, the carbon dioxide that you're releasing here, or at least the carbon that you're releasing here, whether it's carbon dioxide or carbon monoxide, is carbon neutral. So if you cut down a bamboo that grew within 1 to 5 to 10 years, that carbon dioxide that was incorporated into that plant via photosynthesis into its biomass was in the atmospheric circulation just a couple decades ago, right? Or a decade or just a couple years ago. You then burn it, you release that carbon dioxide from the biomass back into the atmosphere. It's in that very recent carbon cycle that we've talked about, and it is carbon neutral. However, that doesn't mean that there aren't negative impacts. So let's talk about some of those a little bit later on, but let's talk about what it is first. There's a lot of sources of biomass energy that we have available. The most common and the most ancient is wood. This is going to come from trees and other woody vegetation, and the botanist in me really wants to define what woody tissue is, but for the purposes of this class, anything that is kind of hard and fibrous-y, woody type of thing. This wood can be milled down into pellets like you see on the bottom right, or compressed down to pellets. And you're going to be cutting down vegetation for this. Now, sometimes you're going to have areas that are planted exclusively for wood production. So it could be that you have some agricultural fields and you have hedgerows between those fields of, let's say, poplar, which is a very fast-growing tree that you can cut down at intermittent frequency to harvest the wood for biomass for combustion. It could be, though, that you're cutting down virgin forest or a mangrove forest or any type of wild habitat. So it can be more or less sustainable. Okay, so this wood can be causing a result of deforestation. Peat, we've talked about a couple times before, is partially decayed organic matter, mostly peat moss, but it's just really any type of vegetation that's in these bogs. It can be in peat bogs, muskegs, or moors. And what you have is anaerobic conditions, very still water, and these peat mosses release acids into the water around them and into the soil underneath of them, which creates these acidic soils, and decomposition is very, very slow due to the acidic conditions and the anoxic conditions. Because of that, you have these layers upon layers upon layers of peat that form over thousands of years, which can be many meters thick. We obtain the peat technically by mining, so you just surface mine the peat away. You can then dry it and burn it for fuel. This is a very old fuel source, and especially in Northern Europe, but also other places around the globe where they have access to bogs, but they don't have access to trees to burn. So let's say Northern Ireland or northern mainland Europe or the Scandinavian Peninsula, have been using peat for many, many generations. One of the problems with this is that it is one of the most stable carbon sinks on the planet, and it does take a very long time to form. So once we mine it out, it's not going to rejuvenate like some of these sources, such as wood. So this is really the most non-renewable of all the sources, whereas the other resources can be more renewable if they are managed properly. Charcoal is a wood product. It is essentially wood that you heat in a kiln let you see up here in the top center, with very little or no oxygen, and that's going to evaporate off all the water, all of the other impurities in it, like all the nitrogen-containing compounds, all of volatile organic compounds, and it basically just leaves those like that black charcoal behind. And again, whenever you see like a dark black material, often it's going to be very carbon rich. So think charcoal, coal, very carbon rich soils, peat, all of those are very dark, and that's what you're seeing up here in the top right with the charcoal. That charcoal is then going to be combusted for fuel, usually cooking fuel, sometimes heating, and it burns hotter than wood. So that's why charcoal was necessary in order to smelt iron. You had to have charcoal be invented in order to have the Iron Age come about, but it burns hotter than wood. And we obtain it from the same sources as wood, so it could be leading to deforestation, or it could be more sustainable. And then we have animal manure. This sounds really weird, but again, a very ancient way to combust, a very ancient way to get biomass for combustion. Think about areas, maybe not so much in this picture where there is a tree, but areas where they have lots of livestock and no trees, nothing else to burn. So let's say that you have a bunch of cows and those cows poop out the back end, and you get those cow patties, which you're seeing over on the right. You dry them up and then you can combust them. And they don't smell when you burn it. It just smells as if you're burning dried grass, which is more or less what most of it is. Crop residues, so this can be very sustainable. So like, let's say that you have leftover stalks of wheat, rice, corn, etc. You can burn those, especially in very rural, agrarian, and very poor areas where they don't have access to electricity and where you don't want deforestation to occur. Now, you could be using that material for other things. You could be composting that material. You could be tilling it into the soil to use as a nutrient, but you can also burn it for a fuel. Okay. All of these are carbon neutral, like I've talked about, and sustainable if they are managed properly. The only ones that I would say really aren't carbon neutral are peat and old growth forests, because it's going to take 1,000 years for that peat to be restored, or 1,000, 2,000 years for those old growth forests to get back to the carbon storage potential that they had as old growth virgin forests. So if we step back and we look at all the ways that we can use biomass for energy, most of what we're going to be talking about through all of this and have been talking about is direct combustion of that biomass. Okay, you can do that for a variety of reasons, but just burning it directly. You can convert that biomass into another product, whether that is solid, gas, or a liquid, through thermochemical conversions. That includes two processes that we're not really going to talk about a lot here, but pyrolysis and gasification. Essentially, they're both chemical processes that use heat that turn one product into either a gas or a liquid fuel. Charcoal, though, is a product of a thermochemical conversion. You just stick it in a kiln in low oxygen or no oxygen setting, and you allow it to change from wood into charcoal. Okay. Chemical conversion of vegetable oil or grease to produce biodiesel. We're going to be talking about that on the biofuels PowerPoint, but because it's in the learning objectives, I thought I'd mention it here. And biological fermentation. So like biological conversion, which is fermentation to produce ethanol or biogas. And again, we talked about that in the biofuels PowerPoint. Don't really spend too much time focusing on this, but I just want to show that there's several ways that we can get the energy from biomass, and that doesn't have to be direct combustion. We can change it into other products along the line, and some of those products have benefits that we can exploit. But regardless of those pathways, all of these are going to be combusted eventually. Okay, and they're going to be combusted in the presence of oxygen. So I have the general combustion formula, which you guys do need to know down here. Notice that the X and Y are variables. So CX, H, Y are variables because you can have all kinds of different lengths of hydrocarbons. You can throw some oxygen in there and make different chemicals that you can then combust. So for example, ethanol is C2H5OH. So it has the oxygen in there also. So there could be an O right there, but don't really worry about it too much. Just know the general formula for combustion. And the main thing that I want you guys to know is that it releases carbon dioxide. However, like I said, it is carbon neutral if we are burning recent biomass. If you have a field of elephant grass and you allow it to grow, that carbon dioxide was in the atmosphere the previous year, and then you cut it down, you burn it, and then that carbon dioxide is back in the atmosphere. It's carbon neutral. Okay. There are other pollutants that can be released, and that really depends on the type of biomass that is burned and the method that you use to burn it. But some of those impurities could include nitrous oxides, sulfur dioxide, a wide range of particulate matter, including black carbon, soot, and ash. You can release volatile organic compounds, etc. Okay, and then all of these are going to have waste heat and some carbon monoxide that comes off of them. So there are biomass power plants. We're going to talk about a very generic one for wood pellets, but these biomass power plants can be combusting really anything, but in general, it's going to be about the same. You have a combustion chamber. That combustion chamber is where you're going to have like a furnace or something that's going to heat water. That water is going to turn to steam. It's going to boil and turn to steam. That steam is going to move along a series of pipes to turn a turbine. That turbine is going to power a generator, which is going to generate electricity. They do provide a consistent energy supply, so they are really good to pair with a other type of renewable resource like wind or solar that is variable, so that the biomass can be turned up or be turned down to match the amount of sunlight that's shining or the amount of wind that is blowing and the other energy resource that is being used. I should also mention that a lot of these power plants are, especially for burning wood or wood pellets, are repurposed or modeled off after, but a lot of them are repurposed coal burning power plants, especially in Europe. So as people are phasing out coal, they're switching to biomass as an intermediate resource, and there's some politics behind that and carbon credits and all this stuff that we don't really have to get into today. But they're repurposing a lot of these coal burning power plants into biomass burning power plants. And you see basically the same thing. You see a pile outside, that could be a pile of coal, but in this case it's a pile of biomass. So a pile of wood pellets or logs like we saw on the other one. Then you have the furnace or the boiler. That furnace or boiler is going to heat water that is in these pipes, turning it to steam. That steam is going to that steam is going to be under pressure because, when you go from a liquid to a gas, you increase the volume of it, which increases the pressure, and it needs to get out some way. It's going to get out through the only way it can, which is through the turbine or through the path that has the turbine. So the kinetic energy of that moving steam is going to spin the blades of this turbine, which is hooked to a generator, which generates the electricity. This will then go to maybe cooling towers or cooling ponds, but in this case, it's going to a condenser, which is going to cool it because it's bringing in cool water from the river in order to cool it along some probably copper coils. But it could be going to a cooling tower. It could be going to cooling ponds. Worst case scenario is that it would be being released as hot water out into a river or stream, but you don't see that very often, especially in the developed world or developed countries. However, even though we have biomass power plants, most of the biomass worldwide is used at the home scale. That could be a wood burning stove in a cabin up in the Rocky Mountains. That could be a cooking fire for somebody to cook their food every single day using biomass in a rural village in sub-Saharan Africa. It just really depends, but most of it is really going to be at home. And remember that about a billion people, over a billion people worldwide don't have access to electricity. All of them have to cook their food somehow. So some of them are going to be using propane or butane, which are derived from petroleum, but a lot of the people are going to be using charcoal or wood that is derived from biomass, right? Which is biomass. So you guys can see some stats here. We have $33 million in electricity in 2020, which is a very small portion of the market, right? We're not talking billions or trillions of dollars, we're talking millions. So it's less than 1% of the global market, but it is slowly growing, especially in Europe and Africa, primarily in Europe because they're phasing out coal burning power plants and they're in their effort to be carbon neutral, they are using biomass instead, which comes with its own problems, especially some deforestation, some land use practices, especially land use practices where they're intensively growing like these quick growing tree farms that they're then cutting down and that can release or result in erosion of the soils and all the other stuff that we talked about with clear cutting. But they are not burning coal. So at least they're not burning coal as much, right? There's still lots of coal being burned in Europe, but some of them are switching over to biomass. Okay. It is not very efficient though, because it doesn't release a lot of energy per meter square. So in terms of like land use, square meters, you're not creating a lot of energy from it. Okay. So we usually think about it as a secondary renewable resource, one that we're going to be sticking with solar or wind, like I kind of talked about, and one that is more of a transitionary resource through this phase out of coal and oil and natural gas and into a 100% renewable market. So to be environmentally feasible, biomass has to be managed sustainably. That means that if we're looking at trees for either wood or charcoal, they have to be cut at a rate less than the rate of tree growth or reseeding or replanting. Okay. There are some very fast growing woody species though. Poplars are a great example of that. You guys know aspen trees from Colorado, and you may know that aspen share a communal root system so that when you cut down one of the aspen trees, it sprouts up another tree pretty quickly right afterwards. It's a little bit simplified of an example, but still, you know that those aspen trees can grow really fast. So you can have a tree that is essentially more or less a full-grown tree. You can get a lot of wood off of it in 10 or 15 years. So it's rapid growth. Bamboo is even more rapid growth. You can like literally sit back and watch bamboo grow, some species of bamboo grow centimeters a day. Same thing with hemp, switchgrass, elephant grass over here, or sorry, this is switchgrass over here on the right. Any of those can be um, planted for rapid growth. And all of those are perennial, sorry, all of them with the exception of hemp are perennial, meaning that you have to plant them only once and then they'll keep growing season after season after season. Hemp you have to plant every year because it's an annual, but it is a very, very, very fast growing annual. When you harvest some of these species, like if we're disturbing the soil in any way that could lead to a soil or a loss of soil fertility, that could be leading to erosion, drying out of the soil. So you notice that over here on the top right, they're leaving some of that switchgrass behind so that it stabilizes the soil, it still shades some of the soil, and they're not really disturbing that soil as much. They are compacting it when they're harvesting it, and you do lose some fertility because all the nutrients that are in that switchgrass are not being returned to the soil, or at least the above ground portions that are being harvested are not being returned to the soil, so you're probably going to be a little bit reliant on synthetic fertilizers. The biggest problem with biomass is that it requires huge tracts of land and lots of fresh water for irrigation to meet our energy needs. It's really not feasible to switch our entire economy to biomass because there's just not enough land space in order to do it. Which leads us to the ocean. We could be growing kelp underwater to be used for biofuels. This is especially promising for biogas or biodiesel, but it could be used for just drying out, compressing to pellets, and being used like wood pellets are as well. It reduces some of that land use problems. It reduces the freshwater use problem entirely, and they can grow much faster than many terrestrial plants, and they can provide some habitat for species in the ocean while they're growing, and you can stagger harvest in areas so that they can provide continuous habitat. And finally, human health. Biomass is one of the dirtier energy sources. It leads to about 4.63 deaths per terawatt hour, and this is primarily due to air pollution, especially indoor air pollution. And the main source of that, the main human health effect is particulate matter, the soot, the black carbon, the smoke that people are breathing in. The worst particulate matter is what we're going to be calling PM 2.5. That's 2.5 microns and below. Biomass combustion releases a lot of particulate matter that's 2.5 microns and less, and that's the size that can get into our lungs, lodge in our lung tissue, and even smaller sizes can enter the bloodstream. So it can result in some serious health complications, including asthma, respiratory problems, and some cancers. Okay. So that's it for this one. You can see on the left, wood is commonly used as a fuel in the forms of firewood and charcoal. It's often used in developing countries because it's easily accessible. You can get, just walk down the street to the forest at the end of the village and start cutting down wood. Peat is partially decomposed organic material that can be burned for fuel. We didn't really talk about a peat furnace, but literally all you do is stick one of those dried blocks of peat into the furnace and burn it. Um, and then burning a biomass produces heat for energy at a relatively low cost, but also produces carbon dioxide, carbon monoxide, nitrous oxide, particulates, and volatile organic compounds, and it can lead to deforestation. So let me know if you guys have any questions, and I'll see you all in class. Bye.